Hi, everyone. How are you doing today? Good. Are you energized? Yes, it's my first time in GOTO Copenhagen, GOTO conference, and it's an honor to be on stage today and share knowledge about serverless development, specifically for Azure Durable Functions. And this is one of the technologies or topics that I'm very close to my heart as a developer as well, working with Azure. So I hope that you will also enjoy this session. And I will be doing some kind of like get to know each other. Maybe this is the day 2 of the conference, but I would like to get to know my audience. So if you have your phone with you, can you please scan the QR code? And we're going to try to get to know together by Mentimeter survey. Let me see. I'm going to switch to one of my screen here. Let's see. Yes. So if you could join during the Mentimeter, I'm curious which country are you joining from? I'm from Sweden. You can count me already. So we have from Denmark. That's the reason why I have the Danish flag in there. Another word. Okay. Nice. We are representing the different parts of the country, and I can see that Denmark is dominating, of course. Let's see. Let's wait. Nice. Nice to know that we are representing the different parts of the world, and nice to meet everyone. I hope you had a chance to say hi to each other. And then, oh, you already went ahead and did the answering part. What are you happy about being here at GOTO Copenhagen? Break from work, testing, not production, learning, new knowledge, new things, new tech, break from work, drop table user. That's fun. Okay, that was an icebreaker for all of us, just to get to know you. So I want to share with you about one of my experience lately, which was I've been traveling for the past last 4 weeks in conferences. So yes, last week I was in Portugal, I was in Budapest, and I had a baggage issue. And one of the baggage issue that I had when I arrived midnight in Stockholm, Arlanda, was this one. So the baggage were stopping every minute, and it took 30 minutes before I could get my luggage, and it is a good example of a deadlock problem. Have you experienced this before? Like, it's like you arrived from a long trip and then you ended up like waiting for 60 seconds, one bag comes there, and then you have to wait for 30 minutes before you could get, and then ended up you're like 1 a.m. in the morning, you're tired, and you got your checked-in luggage finally. And the reason why I share that to you, because in terms of like deadlock problems or problems that takes long time, we want to be able to have this convenience, the speed, and hopefully with the AI technologies that we have today, we can also have our luggages or anything that we want directly in our home, and then, of course, a beautiful, cute dog like that. So imagine if you have an idea, like something you want to do, you want to have a bug fix, or buy something, pay bills, and you want to jot it down or do it, and then you click the mouse clicker. You need to do something, a task or an action, and then you have to wait. Like that. 60 seconds or like that timer. How does it feel? You want to click something, buy something, or maybe it's a lottery that you want to like get first. So you have to wait. And even though it's just 60 seconds, when you're waiting, it feels so slow. Imagine we just like, it's just 30 seconds left. And what would you do? Would you stay cool or would you relax? Who wants to stay relaxed? Or who wants to do this? Kill your computer. We are developers, and even though we're very good in problem solving, we are very, in my experience, I personally can be very impatient, especially if it takes time for me to solve a bug. And I wish I could kill my computer like that, but computers that we have today are expensive, and sometimes it's not our own computer. It's like the computer from the companies that we work for. So today, the point of my talk is going to be about serverless computing, serverless technologies in all platforms. But this talk is going to be focused on Microsoft Azure, which is the platform that I work with every day, and how serverless computing can help with event-driven workflows that you have in your like applications. And I do believe that serverless technologies or computing can help with like concurrency problems, racing conditions, the deadlock problems. Probably it won't save the airport problem because it really depends on the airport guys that works in the middle of the night or the system or the tools that they're using. But we as developers, I believe we can build technologies through event-driven or serverless technologies or cloud to solve such problems that will help our users not wait, including ourselves, when we are trying to do something, because our time is precious. So you could feel that the 60 seconds actually felt so long, especially for me standing on stage. I'm not sure how it is for you, but your time is also valuable. So this is my first time in GOTO Copenhagen. I just want to introduce myself. So I'm from Sweden, neighbor country. I work as a senior Azure consultant. I have a lot of badges, as you can see. I won't have to elaborate them. But I just want to highlight that I am someone that likes to get on stage and inspire others, especially developers, about what I do. And that's my why and my purpose. So it's just good to share with you. So I will be doing a raffle at the end of my session. And you get a chance to get on stage to get the copy of this. So if you want to have signed copies, feel free to scan just a few questions. And I'm going to do a raffle at the end of my talk, like after the Q&A. I'm letting you do the work so I can take a rest for a few seconds. All right, I'll go ahead and continue. The book is also available on the bookstore. You can say hi to John if you want that after the session. I think they will be notifying everybody about it as well. But I want to continue by sharing with you about serverless. In Sweden, who's from Sweden here? Nobody, just me. Okay, I want to share with you about this serverless in comparison to the serverless fika. So in Sweden, we have this fika. Probably there's a Danish version of it, like you get something sweet and then coffee, and then you spend time with your colleagues, family, and friends. But I want to compare serverless in the Swedish fika way. Like, for example, you have monolithic architecture, like a layered cake. You have all the layers of data, the web, the application, and everything is in there. And if it falls down or one parts of that system or infrastructure goes down, then everything goes down as well in the application or system itself. And microservices, you can consider it as like cupcakes, where you have each service for for a specific purpose or reason, and then containers like a box of cookies. Serverless, it's something tiny. You can put it in your pocket, easy to develop, and it's event-driven. You don't have to worry about the infrastructure. And I want to highlight this comparison in terms of control versus productivity. So if you think about the monolithic architecture, like if you have your infrastructure in a virtual machine, of course you have control about everything, but you also have less productivity because you waste time on maintaining the systems or the infrastructure instead of focusing on what you need to deliver in terms of like building functionality for the business and other features that you need to deliver as a developer. Making sense of serverless. So serverless is not really serverless. As you know, there are actually underlying infrastructure behind it. As we know, it's a cliche word if you read it more about it. But I do see a potential of event-driven, like architecture, event-driven solutions in different scenarios, especially in some microservices or function-driven apps. Backend infrastructure is something that we don't need to worry about. And we, as developer, we want to think about developer productivity. So our time is valuable, and when we do our coding and when we do our problem solving, we don't want to be distracted by this infrastructure maintenance that we need to do. So Azure Durable Functions, who among you have tried it or heard of it? Oh, a few, yes. Yes, I assume you also worked with Azure Functions, yes. There's a similar technology also. I know AWS has Lambda also, and I think in AWS it's called step functions. So it's almost similar. I haven't worked personally with AWS, but in Azure Arena, it's called Azure Durable Functions. And it is the extension of Azure Functions, in which you can develop event-driven like code using stateful workflows. My throat is a bit like dry, so I'm sorry. Okay. So durable functions allows you to create stateful workflows in different programming languages. And behind the scenes, it has the durable task framework, as you can see. So you have an orchestrator in your durable functions. And when you're working with .NET, there is actually two types, the in-process and isolated process way to develop durable functions. So there are benefits to developing .NET isolated process. Like that includes like you have full control of the process. You can control of the dependency injection, and you have flexibility of the .NET versioning of it. So stateful versus stateless. So when you're developing with stateful, you have a deterministic orchestrator. Excuse me. So you have a deterministic orchestrator that takes control of your workflow. If it's stateless, as you can see there, you have an Azure functions that does an event, another Azure function that does another event, but you don't have a control about what it does and when it does something. And when it comes to durable function types, there's the client function, which is usually like a trigger. And then there's also orchestrator functions that where you can write the workflow or blueprint of your activities. And this is the heart of the durable functions itself. And then in your orchestrator, you design the activity on what it needs to do in specific different patterns. And a durable entity is commonly used for .NET, especially if you want your entities or objects to be durable. Who have seen this dance before? Have you seen it before? Now you've seen it. So it is a dance called tinikling. So I'm from Sweden, but I don't look so Swedish. I'm originally from the Philippines, and one of the traditional dance that we have is tinikling, and it reminds me of what do you call that? Synchronization or orchestration, because if you look at that dance, if the boy and the girl, or like those that are holding the bamboo, won't move the bamboo sticks, then the dancers will maybe hurt their foot or fall down or something. So orchestration is an example of tinikling, just like this one. No music? Oh, no sound. So orchestrator is like an orchestra that leads the flow of your activities in your event-driven application using durable functions. And it needs to be deterministic. And it means that when you write your workflow, it expects the same result all the time. So these are the do's and don'ts or constraints when you're building or your workflow using the durable function. So it expects the same workflow, right? So you're not allowed to do the random numbers, the GUID, because you know GUID is just like random, like it's not the same results. And then configurations like DB connection strings, infinite loops within the loop is also like the don'ts. So these are like the left and right things that you can do instead of using the undeterministic options when it comes to building or coding with durable functions in the orchestrator. So behind the scenes of durable functions is actually the task hub. So if you can see, one function app is connected to a task hub, which is in Azure. The cloud platform Azure, it's stored on a Azure storage or storage account. And behind the scenes, there's actually a worker or scalar worker that has this automatic scaling out and scaling in, and even can scale to 0 depending on what is the status of the worker. Like for example, if it needs, like the workers are less busy, it's gonna like adapt to it when needed because of this durable task framework. And when it comes to concurrency in Azure functions, There are two types. The default in Azure Functions is static. It's gonna have like, you can configure it in the host level, but there is also dynamic, that it can dynamically determine the level of concurrency that you can also configure in your configuration settings in your function app. So we have this different like basics, like the different types of durable function, like types, like you have the trigger, the client function, the orchestrator in your activities. But there are patterns that actually is suitable depending on the use case. So there is one that's called function chaining. And then there's the fan out, fan in. So you do the, like you trigger it and then you run a lot of tasks and then you zoom, like you kind of like aggregate the result. And then there's the async HTTP API, the monitoring, human interaction, and also the aggregator pattern. Who among you have tried any of this pattern? Which pattern? Async HTTP API. Which one? That one? Okay. Yes, thanks for sharing. We can talk more about how you used it later. So function chaining is just like executing the activities or the functions in a sequence, as you can see. So function 1 is triggered, and then it's going to trigger the next function, like a sequence or like a chain. An example of a function chaining includes like one very example one that I had as a test before is like, I have an Azure Blob trigger because Azure Functions has like different trigger, HTTP, Service Bus trigger. I think they have Kafka trigger, a lot of triggers that you can use. So let's just say you have a blob trigger, and it gets triggered when you upload a PDF file or an image in your Azure storage. What it does in a function chaining is going to kickstart the orchestration. You're passing in your blob data, of course, from the storage, like links to that file or links to that image on the Azure storage. And then you can actually do like integrations, like for example, with Service Bus. So you can connect that blob image data to a Service Bus. If you want to do like make notification using Twilio or an SMS, you can also do that. And then call another functions like a chain. So this is just a very simple example. And I do have a simple like GitHub repo about that you can scan on this QR code. I'm sorry, if someone is taking picture, I'll send the PowerPoint later. So function chaining in action is like this. So you have an orchestrator that gets kickstarted with whatever trigger that you have. Let's just say you have two activities that you want to do when it gets triggered. So activity 1 is scheduled. The orchestrator sleeps. The activity 1 is done. The orchestrator wakes up. The 2 does its thing, like what it needs to do. Let's just say send an email or notify or save data to a database. The orchestrator sleeps. And then activity 1 is done. The orchestration is completed in just 2 activities. And then this like workflow is going to be repeated. And it expects the same results. And that's why it needs to be deterministic. So the orchestrator can be a sleepyhead, just like that cute little puppy. But it is actually good. You know why? Who wants to guess? I can tell you. Because it helps cut the costs. So you know when you have a stateless like functions, usually like you don't have control, like this function is doing this other function is doing that. But if you have a deterministic orchestrator that you control the workflow, and you know that this activity that stops and then this other activities does their thing depending on the pattern that we have built in the workflow, then you can actually take control of the cost because you have control which does the functionality for this specific event. And fan out and fan in pattern this is like next pattern. So very common if you want to execute parallel tasks in like multiple functions in parallel. And this is how it looks in C#. I'm not sure, are most C# developers here? Yes, so that's good. So the snippet example, let's see, I don't have so much time, but this is an example code that you will see when it comes to fan in, fan out. So it supports other languages, but in C#, you just like get a list, you just like do a loop of that list, you aggregate the result, and then you do something about the result of that, and then you call another function if you want to. And then the sync HTTP API if you have like long-running operations for like external clients. I think you have tried that. And this is one simple example, like my example snippet is that I was trying to check the status of my website, and I just like have a if condition, if it's 500, 400, and then I do something about it based on the HTTP response. But it could be something complex, depending on what you're trying to do, like an endpoint that you're trying to call using the durable HTTP async pattern. And then there's also the monitoring pattern that is useful when you're trying to do a recurring task that requires pooling based on specific condition that you want to do. And this is one example of that in C#. Like, if you want to monitor a job status in a specific like task on a virtual machine or another API, you can check the status of that, and then you can set your conditions. And there is actually a durable timer that you can do to perform the next check and take control of that. And then there's also the human interaction pattern that requires a human touch, you can call it. So there are times that when in a specific use case that we need to go on vacation, there are people that needs approval. So there's an automation that to do the process. But then if there's nobody that replies, for example, because someone is on vacation, the approver is out, you can escalate or process it and do the switch between human or a durable timer based on conditions that you have. So this is how the workflow looks like when you're trying to do the approval example. So you have a durable timeout. So let's just say if after 72 hours nobody approves and click the button, approve this, then it will do the automated timer to process the next event that is required to do. So process approval or escalate. And then the aggregator pattern is that it's gonna aggregate the data from different resources or from different time, and then it's gonna be like stateful from different resources. Sometimes it's not easy if you don't have if it's coming from the different resources and they're gonna overlap with each other. You might be wondering, what if I have a lot of orchestrations required in my use case, Jonah? So Azure Durable Functions also support sub-orchestration within the orchestration. So as you can see in this example, you have like a client that kickstarts the event, and then you have a main orchestrator, and then your orchestrator can have multiple sub-orchestrator inside it where you do the activities that you want to do. So there are certain use case scenarios that this pattern can be useful as well, depending on the use case, of course. I believe currently it's supported in .NET, in JavaScript, and Python, but probably it's going to be supported in other languages as well. So this is how it looks in a code snippet example. So you have, for example, an IoT device that you want to provision. So you can have a list of device IDs, and you you loop through the list of that task, and then you're going to do device provisioning on those devices as one of your sub-orchestration, as shown in this example. So what is the pro? You want to know what's the advantage of doing sub-orchestration. It's better organization or cleaner code, because sometimes if you have a lot of functions, it can be very messy and to find things, what it does and how it works with specific functionality. Error handling, so easier to error handling, and you can do retry because durable functions allows you to do retry as well. And then running sub-orchestrations in parallel is a good thing sometimes. And then you can reuse your workflows across the orchestration as well. The QR code will allow you to read more information about it based on the language that you are using for your application. So feel free to grab that later. And then, aside from the sub-orchestration, you can actually do eternal orchestration. So it can run forever. And you might be wondering, what if I made an infinite loop that costs a lot of money in serverless, Jonah? That's crazy. So there are times that this eternal orchestration can be very useful, but there are times that if you have not coded it or architected the workflow properly or designed the workflow properly, it can be very costly, especially in serverless that has you pay per instance and it's very flexible. But there is a way, for example, what if it stops? There's a need, it's buggy. You can, when you run the instance, every time you run a durable functions, there's actually instance ID that you can call, and you can end or terminate it as well. So there are different parameters that you can also take control by code if you want to logically or programmatically take control of the eternal orchestration. So to those that haven't developed with durable functions, there are different ways. The typical IDE that we use for C# or other languages. Good thing to have, especially if you're working with HTTP requests, is the common tools like Postman. Azure Write and Azure Storage are used for developing locally. If you want to know how your instances or what are the IDs that the instances are running, and you can take control of that as well. I have 7 minutes, so let's see how much code I can show you. But things to think about, error handling. These are the things use durable timers, there's a durable functions monitor. If you want to do the retry, if possible, that's good. And then on Azure, there's the application insights that you can integrate with your Azure functions as well. So when you develop, you need to have this Azure function core tools. And these are the things that I shared, that you can have the Azure CLI, in which you have these commands that you can delete your task tab if you want to programmatically or using CLI. You can get the history. You can also purge the history of your orchestration. You can rewind, and you can also bytecode start new if something fails, based on a specific condition. And Azure Functions also recently have support for recent .NET 8, and I think .NET 9 is coming. You can put the Azure Functions and the durable functions itself into a container, like Azure Container Apps. And then there will be a support for .NET Aspire, which is one of the .NET technologies for cloud native recently on the Azure side. Monitoring is something that you can do as well when you're developing locally. So sometimes you want to monitor what's going on with my function. Aside from seeing the instances or the instance ID that you take control or you can terminate using an API call, you can also live stream using Azure App Insights to see what's going on with your function app. So there's like this option for live log streaming on Azure Functions, and it works for both, the extension itself, and then the live metrics stream as well. This one, I think I will skip because I only have 5 minutes left, but I'll just go ahead and move. Let's see what. So I want to show you one example that I want to do, because this is also a good example. Let's see. So I'm skipping now because I talked too much. So I had a real story scenario in which I had used it in my real project like a few years ago. So I work in like both. I'm like a go-to developer, and then I'm also like a lead of the cloud DevOps team. And then it's very special because my team has this like different like group. Like, so you can see there's like consultants talking to manager, the communication is there. But the problem that we had was we have our repository in Bitbucket. We had project management in Jira. We use Azure DevOps for CI/CD. And if you're working with that in a team of different people, different mindsets, it's actually chaos or dilemma. So that made me wonder, are we really in the cloud? I asked myself, I'm kind of like a problem solver. When you see a problem, you want to solve it. And then it takes time to like do this and do that in different tools. So I love this code that says, first solve the problem and then write the code. So I came up with a solution that we will try to use serverless to kind of like automate or solve our own problem. So I propose we're going to use .NET, Durable Functions. We're going to use the Bitbucket REST API, DevOps REST API, and do some notification with Azure Service Bus and SendGrid. And to those of you that haven't heard of Service Bus before, it's like a enterprise messaging broker that has these features. So I was very proactive to say, yes, let's do it. I mean, my boss said, that's good, Jonah, good proposal you have. That will solve our problems. And then you do it, because I had the idea. So I was actually thinking of proposing. So I did the fan out, fan in pattern. And this is what we did. So we had a daily timer that runs 2 a.m. in the morning, and then an orchestration that does the fan out part. And then, my animation did not work so well there, sorry. So basically, we did the fan out, fan in pattern to get the release notes from the Bitbucket repositories with the commits from the developers. And then we used durable functions to regenerate the saved notes in a notepad or an email, and we send it out using SendGrid or Service Bus. So this were another orchestration that we had for sending emails to the stakeholders, to the dev team, to the QA team, or to the external team, or to the release manager. No time for demo, so I'll skip that. But containers is also something that you can build with Azure Functions. And try to solve problems by automating manual tasks if possible, so you don't end up waiting for a long, long time when you're trying to do something. As a developer, we're problem solvers, and if you see something is taking time, be proactive in raising your hand, hey, this is taking a long time, I have a better solution for it. And don't worry about arguing your boss, because probably you have better idea than your boss or manager. So try to work less with serverless and learn by doing. I just gave you an overview about serverless and what it can do. There's a lot of serverless technologies as well in other platforms, AWS and Google Cloud. If you're curious, just keep learning. And then at the end, actually, I found my luggage. That one is my luggage, the one with the beige one there. After waiting for 30 minutes, And then I ended up sleeping at Arlanda Airport because I missed my train back home. So it took time after 30 minutes, but it came out, which actually led me to share to you that it's always good to try to like minimize this waiting time because it will frustrate our users of our applications. So that's all for me. Thank you so much. And that's my dog, Lawrence. Thank you so much. And feel free to ask questions if you have any.